morning, good afternoon, or good evening, everybody. Welcome to Lesson 7.3 on impulse. So let's start off with a definition. What is impulse? Well, impulse is just a change in momentum. So if you speed up or slow down, you have changed your momentum. Impulse tells you how much your momentum changed. You can also change your momentum by increasing or decreasing your mass, but we're going to assume that in most cases, if your momentum changes, it's because of a change in velocity. So the symbol for impulse is a capital J because why not? The unit for impulse is the same as the unit for momentum because remember, all impulse is just a change in momentum. It tells you how much your momentum has changed. So J is equal to your change in momentum or your mass times your change in velocity, assuming that your mass remains constant. Now there's an interesting sort of connection between impulse and force. If you take the amount of change in momentum and divide that by the amount of time that it took for your momentum to change, that gives you force. And to justify that, we can say that J over T is equal to F. Well, change in momentum is mass times change in velocity. Change in velocity divided by time, that's acceleration. So mass times acceleration is equal to force. If we multiply both sides by time, then we get force times time is equal to mass times change in velocity. We're not going to really do any practice exercises with this equation, but it tells us some really interesting things. If you have a certain change in momentum that you have to make, you can either do it with a big force over a small amount of time, or with a small force over a long amount of time. So let's look at some practical implications of that. You may have heard of the phrase roll with the punches, and when it's used figuratively, it means that you are flexible in times of adversity. You just kind of take things as they come and you deal with them. But it has a literal meaning from the sport of boxing, which means that if somebody's throwing a punch at your face, you actually want to twist or rotate away from the incoming punch. And what this does, it actually increases the amount of time that the punch is in contact with your face. Now you may be thinking, this guy's punching me. Why in the world would I want to extend the amount of time that punch is lasting? And here's the reason. Because that punch is going to cause a change in momentum regardless. You have a choice. You can stand there like a goofus and let the guy hit you in the face and go through a large change in velocity in a very short amount of time, or you can roll with the punch and go through the same change in velocity but over a longer period of time, which means that the average force applied to your face will be smaller and it will hurt less and cause less damage. This is a similar rationale for why you want to use a parachute when you're jumping out of a perfectly good airplane. You see, if you hit the ground without a parachute, then you will be going through a large velocity change in a very short time. But what a parachute does is it causes you to go through a large velocity change, but over a much longer period of time. So by the time you hit the ground, you've already bled off most of your momentum in a long period of time, and you can land safely without serious injury. Speaking of falling from a great height, in March of 1973, The Amazing Spider-Man published an issue in which his girlfriend, Peter Parker's girlfriend, Gwen Stacy, was kidnapped by the evil Green Goblin and subsequently dropped from the top of the George Washington Bridge. Spider-Man shoots out his webbing to save her, but you can see this little snap effect beside her neck, which is probably pretty accurate. The sudden deceleration, going from a high speed to practically no speed in a very, very short period of time, was just as damaging to her as if she'd hit the ground. So, inadvertently, Spider-Man wound up killing Gwen Stacy. That's pretty dark. In that same issue, though, for some reason the Green Goblin, who was supposed to be a scientific genius, claimed that Gwen Stacy would have been dead regardless of whether Spider-Man's webbing hit her because a fall from that height would kill anyone before they struck the ground, which is complete nonsense. If simply falling from a great height would kill you, whether you were hit by the ground or Spider-Man's webbing, if you were dead either way, then skydivers would never survive. So this is obviously not true, and I'm not quite sure why the Green Goblin made such a mistake, although they did clarify in a later issue that it was in fact Spider-Man's webbing that caused Gwen Stacy's death. So, if you ever find yourself with superhero powers, perhaps you were bitten by a radioactive wombat or something like that, and you have to save a person who's falling from a great height, and you know it's going to happen, the secret is not to stop that person's momentum in a short amount of time. If you have the power of flight, you want to match downward velocities with the person, grab them, and then gently, gradually slow their velocity. If you swoop in from the side like Superman and stop their downward velocity in a tiny fraction of a second, they're just as dead as if they'd hit the ground. You haven't saved them, you've just killed them a little bit sooner. And on that dark note, we will wrap up with Lesson 7.3 and also Unit 7. So once again, I want to thank you very much for your time and attention. Please hop on over to Google Classroom, where I have an assignment waiting for you. As always, continue to take care of yourself, wash your hands, and I will see you tomorrow when we will move into Unit 8. Till then, take care, have a good day, bye.